Well, let's continue. Up to now, we have plotted the motion diagram, x position versus y position, and then the velocity, and then we want to plot x velocity and the x position, which is going backwards. And now what's next? Well, you do your lab based on the lab uh, handout, the procedure, and then if there are questions, you answer the questions posted in there. So now we are up to here. We graphed the x velocity and same range as the x. Now let's graph acceleration. Along the x direction, the acceleration is basically negative. It's against the velocity. And then there will be so since acceleration, the object move to the left, and so it's negative, so the acceleration should be something like positive. Okay, now then let's continue doing this. So we are working on number 4. Acceleration along x direction, that's the horizontal direction, right? So now we do here. Let me delete this one. All right, so once again, another graph. So here's another graph. So then you choose the x acceleration and then versus time. Acceleration is basically constant positive, and just think about it. Acceleration is going to the right. So for example, if the object going this direction, and then the resistance will be against it. So currently the ball along going to this direction. So it's like a wind. The acceleration, reduce it should be small, but it's against the velocity. So then that's this plot. So if you simply do this, so see it's a positive around 0. It's not that big, but then average is 0 because the up and down just because of the artifact, because I clicked not very uniform. So that's this part. Acceleration is in meters per second squared. See, and you see, and positive and negative. If you look at the average, is about 0. If you doing this, you can say mean is about 1.2, not very big. So now what's next? You flip back to this part. And so now we're going to the vertical direction. So y position, velocity, and acceleration. Then you are done. So now let's plot the y direction, produce a graph. Guess what this graph will look like? So we go back to here, get another one. So total, you need to get 7 of these graphs. And important is not just plot, you should understand it. All right, so here. Now, another graph. So now we do y direction. We have 3 plots. Okay, and double click here, and you have another graph. So then vertical y position object and versus time. So that is beautiful. In y direction is simply a parabola. So the time in vertical direction, it's like this. At vertical direction, it's with the time goes on, the picture is taking goes up and goes down. So if you look from the side, parabola like this, but if you look from the side, it goes up and goes down. So that's this graph. But let's do just plot. See, that's in the y direction. So y position and it goes down. So that is the position versus time. Now, what's interesting is this y direction velocity. Velocity, so this goes up, it's positive, positive. At the top, it's 0. And then velocity is 0. And then it goes down, then negative. So the velocity plot will be like positive, high velocity, and reduce and slow down when it's hit 0. That's when the object goes to the top. When it goes to negative, and then of course accelerating down. So now let's have a plot for the velocity. Okay, and then another graph. So let's see y velocity, vy, and then versus time, and then you will see here. So that's this going. So if I ask you a question, at what time the object reach the top, or the tennis ball reach the top, you would say, well, when the velocity goes to 0, it starts very fast, but it slows down, and 0. That's where at the 0.76 seconds, the object. And then they go back down negatively. So negative, faster and faster. But if you look at this graph, the position, if you say what time it goes up, and well, you just simply look at the top of this. So that's when it goes to the top, and then this goes up. That's the in the time. So this is the main graph for the vertical direction. It goes up and goes down. And then you took a velocity, it's up positive, 0 on the top, and negative. That's polar. And then if you look at now the third graph, let's look at flip back to our lab. What are we supposed to do? And then our lab will be, and the last one is the acceleration in this one. Acceleration should be a constant acceleration, should be constantly negative value. See what that is. Okay, and then because that's gravity, that's g. So that's simply kind of g. Let me excuse me, I will disappear for a moment. And then you will have this. So I will do y acceleration, and then it's supposed to be a constant. You don't see anything. It's supposed to be a negative somewhere here, and you do like this. It's here. So it's negative. Well, it's kind of negative too big, but that's probably due to the error. But important is this negative acceleration. If you look at some very high, some very low, it's negative in the downward direction. So that's acceleration. So you have how many graphs? So you should recognize these graphs, what each of these are. And we will talk more about the two-dimensional motion when we talk about vectors. So this is serves as the basis for the study. But theoretically, the acceleration is supposed to be a constant like this. Okay. But of course, the rest is kind of error. So you go like constant going like this. If you fit into a horizontal line, so linear. Okay, and it's going a little bit back, so it's supposed to be negative, but here is not quite. So the acceleration is not accurate because it's a second derivative in calculus. So, but you just understand that this is supposed to be a constant negative, but because the data is rough, sort of up and down, but in fact that this is negative value. All right, so once you have this, you're done. So you should be able to answer all the question about this. And then now to finish up the lab, you need to make a snapshot of the whole thing that just show that you did this. So you would do on Windows computer, I think there's on either Windows or Mac, you just Windows Shift S, and then you will make a copy, Windows Shift S, and then the cross show up, and then you make a copy. So that's yours. See, I did this again. And then you go back to the lab, Okay, so then you did all the 7 graphs, 1 through 7. Okay, and understand what they are. And then you go here. This is the new one you did, right? So I click this and I replace with Control V. So that's the new one I just did. So you replace mine with yours. of course, you should start with your own video. All right, so this actually paved the ground, the road for study the two-dimensional motion using the common phenomena parabola as a starting point example. And we will talk more, save this project, we'll continue to do more around this. You can do analysis, you can do curve fitting, but that's the starting point. All right, hope you understand. This is a second part of the instruction film. I divided into two parts because if the video is too big and it will take a lot of space, it's hard to download. But do watch this video from beginning to the end. And then actually you notice that you will finish it faster, or you can have the video on the side and keep doing your own. Bye bye for now.